So last class we talked about airport policy. That was sort of a warm up to get you thinking about policies, what they look like, things that can go wrong, trying to motivate the fact that they can be more complicated than they seem at first glance. So that's a very sort of human-focused policy. It's something that involves actual human beings. It's something that you've gone through. It's a very common policy, that type of thing. I'm going to give you a second example. So this will be sort of the closing part of the course, but it'll take us 2 lectures to get through, of another policy. But this is a policy that's in your browser. So it's fully automated. But what you'll see is that a lot of the same decisions are sort of made. It has the same kind of problems. There's escalation of privilege problems in particular. Different things are in charge of different entities are involved. Usually when you start mixing different entities up, that's when it gets sort of complicated in terms of how you want to enforce it. History plays a big role as well. So things are the way they are because they were that way 10 years ago. You don't want to break compatibility. You want to have things that are backwards compatible. But the web looked different 10, 15 years ago than it does now. So these are all kind of the themes that we'll pick up when we look at this. Okay, so the same origin policy is something that's implemented by your browser. The other thing I'll mention just as a slight logistical point is you'll hear about this in other courses. In particular, you'll take like a web security course. And so some of this will be similar. You'll see like some of the same attacks and things like that, but the focus is really different. So in this course, we're really looking at it from a policy perspective and thinking, I'm not here to just show you the cross-site scripting attack or whatever. It's more to show you why the policies are the way they are and why these attacks are possible given that the policies are the way they are, and how could you change the policies to eliminate them. Okay, so some of this might be stuff that you've seen before, but hopefully you see it from a different angle in this course than you would see it in other courses. Okay, all right, so this is a browser policy. And in general, at a very high level, what it concerns is when you have a website that weaves together content from multiple sources. So we've seen this already. We saw it for SSL. It created complexities for us in SSL because if a website has some resources that are loaded over HTTPS and some of it's loaded over just plain HTTP, does it show you the lock, right? It's kind of like half of your page is over SSL, the other half isn't. How do you handle that? So that's actually another example of a policy. So a browser implemented a policy. So same setting for this, but it doesn't have anything directly to do with HTTPS, but HTTPS will play a role. Okay, so it's a browser policy. It concerns websites that weave content from multiple sources. And this is basically like every website now. Okay, so this is like the modern web. And in general, what it's meant to do is try and decide how are you going to isolate resources from different sites or from different sources. So for example, if I load a page from Concordia, Concordia has some relationship with Google, so they load. So some of the website you're looking at has some stuff that's put there by Google. Maybe it's a Google search. So Concordia they don't want to design their own search engine. They don't think they can do a better job than Google. So that's fine. So you'll see the Concordia page. There'll be a search bar, but the search bar is actually powered by Google. What does that mean? That means that like Google maybe has some JavaScript that's running on the website. Okay. So now you have a site, and from your perspective, it just looks like a site that came to you from Concordia, but behind the scenes, it was actually loaded from Concordia, it was loaded from Google, et cetera, et cetera. Okay? So because Google has something on that web page, can they kind of see what Concordia is doing? Like say you interact with the Concordia resources, does Google know what you're doing? Or vice versa, let's say you type something in the Google search bar, does Concordia, because you loaded it from Concordia, do they know what you're typing into that search bar? Let's say that you're logged into Google. So when you type something in that search bar, does it know that it's you because you're logged into Google, but it's actually, you're not on Google's page, you're on Concordia's page, right? So does it know that this is you, the person that's logged into Google, or is it like completely independent? So anyway, these are the kinds of questions that you would have. And so you have to come up with a policy for, what does this look like? How do we segregate this content? What interactions are allowed? What interactions are not allowed? And as you can imagine, it gets kind of complicated. Okay. So browsers first started to deal with this back in the 90s. So the first sort of big browser was called Netscape. You might not remember it, but Netscape was popular in the 90s. Then Microsoft added Internet Explorer to their operating system. Apple eventually added Safari. And then Netscape kind of died when Firefox came out and Chrome and things like that. It actually kind of died first. Technically, Mozilla, who owns Firefox, bought out Netscape. So some people think of Firefox as sort of the modern Netscape. But anyways, so it's a standard by Netscape. So the same origin policy actually has two forms that are almost the same, but they're technically two separate things. But we're going to gloss over the difference, and we're actually going to talk about them as if they're the exact same thing. So in 1994, they came up with a policy for what are called cookies. So hopefully you know a little bit about cookies now because you did your Ghostery project. But we'll go through what cookies are and how they're used in a second. So if you don't know anything about cookies, don't worry about it. But anyways, so they came up with a policy for how you're going to handle cookies. In particular, if you have a website, it's composed of a bunch of different resources, and some of those websites have set cookies on your computer and other ones haven't. Are they allowed to see each other's cookies and those kinds of things? Okay, so they came up with this cookie policy. And then the next year, they looked at it and they said, we should take this policy and we should apply it to like all kind of web resources. Okay, we should sort of expand it so that will look very similar, but it won't just be for cookies. It will be for, in general, resources that are weaved together. So cookie is a web resource. It's a little different. It's not something you see that's on the page itself. It's something that's passed in the header of the packets. But anyways, it looks similar. So then the same origin policy came out the year later, and the primary motivation for it was active scripts. So if you have a website and you're going to run 5 JavaScripts, all from 5 different sites, can they interfere with each other? Can they access each other? Let's say you load a script from Google. Can that like overwrite the entire page that you're looking at, or is it kind of confined to like some sort of box? Like what exactly are the bounds on scripts when you start weaving things together? Okay, and so the policy for cookies and scripts are very similar in terms of how they isolate things, but we'll sort of deal with them separately. And historically, they were developed kind of together. So the same origin policy applies to active scripts. It also applies to resources. So these are like passive. You basically have active things on the website, which are scripts, which are dangerous for reasons that we'll display or discuss. And then you have passive components of the website. I'll just call them resources. That's probably a better word. So things like images and that kind of thing. Okay. All of this, we won't go into the bloody details of it. But in your browser, it sort of organizes all the resources that are loaded in a data structure, which is called the DOM. It's in the form of a tree, so it's called the DOM tree. But anyway, that's how your browser, when you're looking at a page, it's how it keeps track of all the resources that are loaded in the page and what their relationship is between them. Okay. The general nature of the SOP, and there's going to be a lot of fine print with it, but in general, the sort of theme is that what we want to do is we want 2 resources that are loaded from different resources, different origins, so that you see that the same origin is in the term here. To be good at, maybe I'll change sources here to origins, since that's exactly what it means. Okay, so the SOP basically says if things come from the same origin, then they can interact with each other, no problem. If they come from different origins, we want to put some isolation. Okay, so we don't want them to be able to like fully see each other. Okay, but there's going to be some red tape with this. So same origin resources can sort of interact, and different origin resources are going to be isolated to some extent. Okay, and just as a reminder, by resources, what we mean are, so here's like some website. Make it look really pretty. And then you have some stuff on it. So you might have different images. You might have different scripts. So the website itself might come from some origin like A. We'll talk about what an origin is. What is that? Like an IP address? Is a URL? What exactly is an origin? That's a thing that we have to resolve. You might have something that comes from B, something that comes from C, something that comes from D. This might be an image. This might be JavaScript, and this might be JavaScript. Okay, so we got to figure out how we're going to allow these things to interact or not interact, or what isolation looks like for these different things. In general, resources you can think about in this sort of way. So there's kind of three categories of resources. There's things that get added to the content of the page. Okay, they're inside the website itself. Okay, and these can be active or passive. So something that's active would be like, for example, JavaScript. Something that's passive would be like an image, JPEG, or something like that. The other kind of resource are things that aren't in the content of the page, but they're communicated with every request and response. Because they're not in the content of the page, they're considered meta information. So they're information that's sort of at a higher level. You would find them in the header. If you looked at HTML as a structure, you'd see that there's some stuff in the header, and then there's the content of the page. So this is meta information. And the absolutely most important example here are cookies. Okay, so how we isolate JavaScript, how we isolate JPEGs, and how we isolate cookies, they all have kind of the same philosophy behind them, but some of the details are going to differ between them. So we'll take them one by one. I'll start with cookies, and then we'll move into active website next. Okay, before we do, I'll just say what the general security goals are for your browser. So the first thing that the browser wants to do is they want to enforce some sort of integrity, which you can think of as what you see is what was actually sent. Okay, so what you see wasn't interfered with by some of the other things that got weaved into the website itself. The other concerns privacy. So what you provide to one origin can't be seen by others. Okay, I type a website into Concordia's website because I'm logging in. It happens to have something running. You know, let's say it has an image that it loaded from Google. Does Google see my password? We don't want that. Okay. If it has a script running from Google, We also probably don't want that, but as we'll see, the situation there is going to be different. Okay, so the same origin policy, it has these general goals, but it doesn't always achieve these goals. And yeah, and we'll see that you have to understand what it actually does to sort of align your mental model. So for a long time, people, like for years and years and years, people didn't understand how this policy worked. They thought it worked a certain way. It ended up working a different way, and then they left their websites vulnerable to attacks that have like really fancy names that you've heard about, like cross-site scripting and cross-site request forgery and like all of this stuff. Okay, so we will talk about those attacks, but I'm going to really simplify them, and you won't even know that we're talking about cross-site scripting per se until the very end when I show you the name of it. Okay, so before we get there, let's just do a little background. So I'll start with the cookies example. So before we talk about the cookie policy, let's just talk about what cookies are, what they're used for, all of that kind of thing. Okay, so when you send stuff back and forth between a website, let's say here's Alice. So the most common thing she would send, there's a bunch of different things, but she might send a request like, hey, give me index.html of your website. So she'll send it. We'll assume that she's already done DNS, so she knows the IP address of where she's going. And then the server will send back a response. Okay, so this is, most things are request response. There's a couple other things that you might do. What will happen is the request itself, you don't really see. Your browser creates it. It sends it off to the website. So it's largely meta information. The response is going to be a mix of stuff that's in the header, and then there's the actual like HTML document itself. So it might say, okay, here's the HTML file. Okay, so it can communicate some things in the header which aren't displayed to you as a user on the website, and then there's the actual content of the website itself. Okay, so cookies live in the headers, so you never see them directly. They don't like show up on your website or anything like that. Okay, but they are there. Okay, what a cookie is it's basically a piece of information that any website can set. So let's say we have Google here. And we'll make it .ca. And so what Google will do is when you send a request for the first time, say you've never gone to Google before, you just bought a brand new computer, you turn it on for the first time. Okay, you'll send a request to Google, and Google will say, hey, I don't know who you are, I don't know anything about you, anything like that. What Google has the option of doing is doing what they call what's called setting a cookie. Okay. So what will happen is the cookie will come back in the response. Okay, so the response will include an operation to set cookie. Okay, and all a cookie is just a number, basically. You can think of it as a key value pair. And so what your browser will do is it will see, oh, Google wants to set a cookie, and so it will write down your browser will write down all the cookies that are set by different websites. So it will say, okay, I've seen my very first cookie. It's from google.ca. And it has this particular number, okay, or this value. You can think of it as a hex number, which it could be data or it could be a number. It depends what you want to think about. But it's just a little piece of information. It's very short, and your browser stores it, okay? Then what happens is, let's say you keep interacting with Google. So you send your search results. They send back the response. Now you're like clicking next page, next page, next page. In order to do that, you keep sending requests. Okay. The next time you send a request, what happens is your browser will see, hey, you're about to send a packet to google.ca. Let me quickly check if you have any cookies for google.ca. And so the cookies are called funny enough, a cookie jar. So that's what you call where you store it. So they'll check their cookie jar and they'll say, oh, I see that there's a google.ca cookie. What your browser will do is it will actually append it to your request or prepend. So we'll add it to the header of your request. So it says, you're about to send this request to google.com. I'm going to add in the cookie. So they'll add in that number for you. So then when Google receives it, they see, oh, there is this cookie. Okay? And the point of this is that Google can see that this response that they set, which set this cookie at this particular value, is coming from the same person who's sending this request. Okay? So they can link these two together as coming from the same person. All right? Why is this important? So it has a whole bunch of different kinds of functionality. But the most important one is it's what lets you it keeps you logged into websites. Okay? So for example, let's say you go to Gmail now. So you go over to Gmail and they say, okay, I don't know who you are. Give me your username password. So you type in your username password. Okay? And then they say, okay, that's great. I know who you are. Then they send back your inbox. Okay? Now, if you click on the first message in your inbox, you're sending a new request. Okay? How do they know that you're the same person that just logged in? Right? So what they could do is you might have to type your password on every page. Right? So it's like, here's your inbox. If you want to read your first message, give me your password and then I'll show you your first message. And then you want to go to the second message? Sure, give me your password. Okay? But that's not how the web works, right? You just sort of log in once and then somehow it figures out, oh, you're the same person that's coming back. Okay? How does that work? You might be like, well, maybe it's based on your IP address, right? Well, everybody in Concordia that's on Concordia Wireless has the exact same IP address, okay? So it's never the thing that I'm like browsing through my Gmail and all of a sudden I switch to your account because you logged in with the same IP address, okay? IP addresses are not reliable, okay? You can't base a decision that this is the same person because they have the same IP address, okay? Similarly, if you're logged into Google and then you switch IP addresses, say you go off wireless, say you're on your phone, you leave Concordia, you're walking down the street, all of a sudden you switch to the cellular service. You're given a completely different IP address, completely different carrier, your ISP is completely different, everything about your internet connection is essentially different, and yet somehow you're still logged in. Okay? So how did that work? How does a website basically persist the fact that it knows that it's talking to you as the same person? And so that's the answer. That's what cookies are the answer to. Okay, that's the problem that cookies solve. Okay, so cookies sometimes get a bad rep because of privacy things, and we'll get into that in a second. But a web without cookies is like a web where you log in and then the website forgets that you logged in or it forgets who you are. Okay, so you essentially cannot use the modern web without cookies. They're absolutely essential to how the modern web works. Okay, so what will happen is just to put this in terms of that exact scenario, here's Alice. And so in this case, she's going to whatever, let's say gmail.com. She'll log in. What Google will do is they'll have their kind of database in the background. Okay, so they'll have the username for Alice. They'll have the password, hopefully hashed, salted, all of that stuff. I think we talked about this in this class a while ago. Maybe we didn't. But anyways, they'll have basically your password in some protected form. And then what they'll do is when they log in, they're going to check your password. So you'll log in with your username and your password. And then they'll check whether your password matches. They'll hash it and say, okay, it matches. Okay. Then what they'll do is they'll set a cookie. And it will have some particular value. Usually a big, long, kind of, 256-bit value or something like that. Okay. I was going to make this in hex, but I've already used non-hex characters. We'll think of this as base 64. So they set some particular value for it. Okay. And they store it. Okay. So they store it here as well. So they say this user came, they logged in, and this is the cookie value that I gave them. Okay. Then what happens is when Alice, she's looking at her inbox and now she's like, I want to read my first message. So she requests the first message. What her browser does is actually when the cookie's set, then the browser adds that cookie to Google's browser, or sorry, to Alice's browser as well, under Gmail in this case. Okay. So when it sees a request go out, it goes through its whole cookie jar and says, this request is about to go to gmail.com. Do I have any cookies that match gmail.com? And so we'll go through all the cookies and say yes, yes, no, 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 yes, 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 yes. And all the ones that match gmail.com, it will append or prepend. It will put in the header for it. Okay. So the request will go out and the browser will add the cookie value. And the cookie value here is this particular value. Okay. Then Gmail will receive it. And they'll say, okay, somebody wants to see the first message. They have this particular cookie value. Do I have anybody with this cookie value? Oh, yeah, that's Alice. So I know it's Alice that's talking to me. Okay, it's the person that was logged in. I see that they're actually logged in here. Okay, so these are sometimes called session cookies because they maintain a session for you. What would happen if Bob was sitting here, or let's say Mallory, so we have Mallory, and she happens to be sitting on the wire here. And she sees this cookie get set, or she sees any response, any request from Alice to hear with this cookie value. She takes that cookie value and she starts prepending it to her messages to Gmail. She just shows up to Gmail and says, hey, give me Alice's first message. Here's my cookie value. What will Gmail do? It will log her in and show her the message. Okay. Sorry? So you don't even, it will bypass it. It will just think that this is coming from Alice. Okay. So if you steal the cookie, it's kind of like stealing the username password. Okay. It's going to be slightly different, but it's almost exactly the same. Okay. So if you steal the cookie, you get access. So this is called session hijacking. Probably heard that term. Just means that you steal that particular session. Okay. Now, if I have your password, I can log in until you change your password. If I have your cookie, I can also log in as long as that cookie is active. Okay. But what Gmail will do is every now and then they'll cancel the cookie. Okay. So if it's been 30 days, for example, they might close it. Or let's say the real Alice comes in and says, I want to log out. I want to explicitly sign out. Then what Gmail should do, different websites, it's up to however they want to enforce it. But what they should do is they should go and remove the cookie from their database. So that's no longer considered a valid session cookie for that website. So then if the attacker comes with the same cookie, then it's no longer there. Okay. Then when they log in with their username and password again, they get a new cookie. So this cookie is sort of unique. So every time you log in, you'll get a different cookie. Or if you have 5 devices, you'll have a different cookie on all the 5 devices. In the database, there could be lots of cookies that correspond to the same user. It's not necessarily one cookie. Okay. But if I can steal your cookie, then I steal your session, and then I can log in as you effectively. Why can't, so this would be crazy, right? We don't hear about this. I mean, think of who Mallory could be. It could be Concordia's Wi-Fi. It could be the ISP, right? There's a lot of, there's a lot of potential middle people in my connection to Gmail. Why isn't my session getting hijacked all the time? Okay, because of HTTPS. Okay, so SSL will wrap both the request and the responses themselves, also the headers. Okay, so a while ago we had a discussion about, like, think of SSL as an envelope, right? So if HTTPS or SSL, call it HTTPS. It's kind of like an envelope. Some stuff is inside the envelope and some stuff is not inside the envelope. Okay, so inside the envelope is obviously the body or the content of the websites itself, the requests, On the outside of it is the URL that you're going to. Okay, so the destination. So that's not hidden. Otherwise, the envelope won't find its way to the right server. Okay, and then cookies are like, okay, are they inside the envelope or are they outside? They're in the header, right? So they're kind of above the content, but they're below the URL. So where exactly are they? Well, it turns out that they're inside too. Okay, so the content as well as all the headers are inside the envelope. Okay, so the cookies are protected by HTTPS. Now, websites didn't always use HTTPS. Okay, so websites would often, we went through a phase where basically no one used HTTPS. Then we went through a phase where people want to protect like before we use HTTPS, you would actually send your password in clear text. So anyone who was on the wire would just steal your password. Okay, then people realized, oh, that's bad. So then websites started to give you the login page over HTTPS, but then when you actually transfer to the main page itself, it would switch you back to HTTP. Okay, and this happened for like very famous sites, like even Facebook. Like Facebook's it's old enough that it actually behaved this way for a long time. So Facebook, you would log in over HTTPS, so it was hard for me to steal your password, but then from then on, you were HTTP. Okay, then what happened is somebody wrote a really nice piece of software called Firesheep, which was an extension that you could install on your browser. And you would go on a Wi-Fi network, you basically click a button, and it would do some attack on the wireless protocol that I won't talk about, but it'll basically get everyone routed through your computer. And then anytime someone would look at Facebook or Twitter or whatever websites like this that didn't have HTTPS for the actual sites itself, it would grab the cookie out. And the user interface was really smooth. So like basically you would run Firesheep and it would just like kind of pop up with people on Facebook, and then you could just double click their name and then it would just open their Facebook and you were logged in. And so this attack was always theoretically possible. It's just that you sort of had to be a hacker to do it. Now all of a sudden anybody could do it, right? Like just point and click. And so within like a month or two of that coming out, all the major websites switched to HTTPS for the whole session, not just the login page. Okay, and now it's like even if you aren't logged in, say you're just reading the New York Times, now you might be over HTTPS even for those kinds of experiences as well. So HTTPS adoption for the best of the web has increased a lot. Okay, so it will protect you from this session hijacking, but if you ever, well, first off, if you don't log in over HTTPS, your password could get lifted. And if you're logged in, like keep me logged in and not going over HTTPS, then your cookie could get lifted, and then someone could hijack your session. Okay, so you really need HTTPS to protect that whole interaction between the two websites. Okay, similarly, let's say that Mallory isn't on the network. Say she gets possession of your computer, right? If she has possession of your computer, your cookies are stored there. Right, so if you don't have like an encrypted hard drive or something like that, she could just lift them off of your computer and then just go and log in. Presumably, she could just turn your computer on and log in anyways. So once you have kind of physical possession. But anyways, if let's say you get malware on your machine, your malware is able to go into your cookie jar and send it back to the creator of the malware, then they can compromise your accounts as well. All right. Another thing that websites have done in sort of response to this is a cookie might get you kind of logged in, and so you have certain privileges, like you can read people's emails and send emails and things like that. But then certain tasks are higher privilege, like if I want to reset your password, then I might have to log in a second time. So I might have to actually send my password explicitly to do that. So if I hijack and then try and reset your password so I have permanent access and lock you out at the same time, I might not be able to do that as well. So those are the two kind of responses from websites themselves. Yep. Sorry, say it again. Yeah, so if you save passwords in your browser, like using a password manager, that kind of thing. Yeah, so it's very similar as well. So once again, if I get physical possession of your password, usually they're kind of wrapped in a master password. So I'd have to know your master password somehow. But if I can get malware on your machine, I'll just wait for you to unlock your password store, then I'll steal everything. Or I'll have a keystroke logger, so as you type in your master password, I'll steal it. So yeah. Once your machine is sort of compromised, it's very difficult to protect anything in that environment without using super fancy like trusted hardware and those kinds of things. Yeah.
For changing passwords, so usually they'll ask you your old password. Is it sort of like response to this?
Yeah, exactly. So it's the same idea too as well. Yeah, so they're like, we don't know for sure that you're the original user. We see that you have the same cookie as them, but we know it's probably a little easier for you to steal a cookie than to steal their password. So let's just make you put in your current password or old password just to make sure that you actually are that person.
Was that what you're referring to as a higher level of privilege?
Yeah. So that's right. So it's a higher sort of level of privilege. So you, if I show up with just a cookie, I'm privileged to do certain tasks with your account. And if I can show up with a password, then I have a higher level of privilege. In other words, I have more access to things. Yeah. So accounts kind of have two tiers of authorization. There's the person that just comes with a cookie, and then there's a person that can come with a password and a cookie, presumably, as well. Yeah.
Is it possible to use a same cookie on two devices? Like I know my cookie, I could maybe use it to craft a packet on my phone and then send it to the server. So what happens in that case?
Yeah, so it depends on the server itself. So in most cases, it would work. Like you would just copy the cookie over, and then if you browse to that website, that cookie would get sent, and then they would log you in.
So like I'll have two devices with the same cookie.
Yeah. So if you could synchronize like between your iPhone and Safari, if they synced your cookies back and forth, you could have the same cookies on both devices. The website might check and say, it looks really weird that you were coming from your phone for the last 5 years and all of a sudden you're coming from a browser, right? And so some websites are more proactive. Like if you show up with the same cookie, they won't just say, go ahead and log in, right? Like if your IP address changes wildly, like you're in a different country or you show up with a different device or something like that, they could do that, but that's up to the website. So the website has their own policy for what they do for cookies themselves. Yeah.
I have seen sometimes like if you have do a checkout on Amazon, for example, you put it in a like checkout cart.
Yeah.
And I think it is stored in cookie on your browser.
Yeah.
When you open, you see those items again.
Yeah.
But I have seen the same thing like if I open my Amazon app,
Yeah.
I see the same items in my cart.
Right.
So how the application is synced with the cookie on the browser?
Yeah. Okay. So what happened is this is actually a nice segue into you've heard about cookies in terms of privacy, so it's sort of using the same type of approach. Let me just put the header and then I'll answer your question and then show you a sort of more evasive example. Okay. So what happened is you browse Amazon, you add some stuff to the cart. Now, let's say you have a phone fresh, you just bought it from the Apple Store or Android or wherever you got your phone. You never turn it on. If you open the Amazon app, there's absolutely no way your cart would get synced. Okay. What would have happened is at some point you were logged in on both devices. Okay. So what it did is it actually assigned that to the cart that corresponds to your username, right? And it sees that you have two different cookies that were logged into that username. And so when it sees those two cookies, then it assumes that you're the same person and then it updates that cart.
Okay.
Yeah. So if you were logged out on either, the cart shouldn't be reflected. But even if you log out, the website can still remember your cookie, right? So that's the other thing about it, right? Is that, once you log out of a site, then it can still remember your cookie and still knows who you are. Or at least it knows that you were the person that was once logged in as you, so it assumes that it's you. Yeah. And even if you log out, like sometimes it will auto-populate your username. It'll be like kind of like, I know what user you are, just put your password in again. Yeah, and that's all through cookies.
Yes, Professor, question. Nowadays, most of the browser thinks there's an option of disabling the cookies.
Yeah.
So if you disable, still the session hijacking attacking web?
Yeah. So if you, So if you turn cookies off completely, then it will not work. So then cookies won't work, but then you won't even be able to log in. You won't have a session. Like it, not only does it break session hijacking, it just breaks the concept of a session in general. The option that you're referring to is a good one, which we'll talk about in a sec. It's actually for third-party cookies. So there's what's called first-party cookies and third-party cookies. And so that's an option that will turn off third-party cookies, but it won't turn off first-party cookies. Most browsers don't give you that option. Yeah, so that's like a small technical difference. And so what it does is it kills off like a small percentage of cookies, but you still have like a ton of cookies in your browser. Yeah.
So if I enable keep me login option,
Yeah.
so does that mean I have a permanent cookie
Yeah, exactly. So then when you say keep me logged in, the thing about the web is the website probably has a permanent cookie whether you click that or not, right? But what the website will do is it will honor that cookie. When it sees that cookie, it will say, well, I know that you're a person that wants to be kept logged in, so I'll keep you logged in. But even if you log out and unclick it, you probably won't delete that cookie. And so your browser will still send it. And so the website will still know who you are. It just won't log you in when it sees you. Yeah? Does that make sense? Yeah. And so this hopefully sounds like it's starting to tread on like sort of a privacy violation, which we'll talk about in a sec. Yeah.
Okay. What I could get from what you said was cookie serve as like a session key.
Yeah.
So is it actually different from the session keys that negotiated during the HTTPS connection?
Yes. Yeah. So the right. So session keys and session cookies are different things. Yeah. So the session cookie is a cookie. The thing that you're talking about, the session key, that is an HTTPS specific thing. It has nothing to do with cookies itself. Yeah. So that's the key that's going to keep your connection confidential. It's used for encryption and decryption, as well as integrity, message integrity on that channel. This is something that lives longer. So in SSL, as soon as you disconnect, then you lose that session key forever. But your session cookie persists. Yeah.
And you've logged out of the web server for a long time, and then your cookie in the database has been invalidated.
Yeah.
And now on your local computer, you still have the cookie linked to that web page.
Yeah.
And before you send your package, that package gets like the cookie gets appended to the package.
Yeah.
It gets sent to the web server.
Yeah.
What happens? Because now you have like a cookie that's already validated.
Right. So totally up to the web server themselves, right? So they can decide how they're going to handle that case. But what would happen most commonly is they would still keep a record that that cookie belongs to you. What they won't do is they won't automatically log you in. So they'll say, hey, I know exactly who you are, but you told me that you want to be logged out. So I'll just pretend that you're logged out, but I actually know who you are. Yeah? Yeah. And so what will happen is even if you go to a website and log out, that website still knows who you are because you keep sending that same cookie. And because you were logged in at one time, then that cookie is kind of stapled to your identity.
So now when you log back into the web,
Yeah.
it gives you a new cookie, but it still remember the old cookie.
It doesn't always give you a new cookie, so it might just reactivate that existing cookie. It could give you a new cookie, but it will keep a record of all the cookies you've ever been assigned. So whether it gives you a new one or not has no difference. The only difference is if I was somehow able to steal your cookie, then a new cookie is a little more secure because it would prevent someone from hijacking your previous session. But whether the website refreshes that value or not is up to the website. And even if it does, it can still keep a record of your old cookie and say, these two cookies belong to the same person. Yeah?
It's the management of cookies it just be very big then.
Yeah, exactly. So someone like Google will have, tons and tons of cookies and tons of users, and it is a big operation, but they're a big company and they have big databases and they have anyway, fast algorithms and things like that for dealing with it. Yeah.
So you don't actually have an option to turn off the first party cookie.
That's right. So you do kind of have the option. So especially if you install an extension, it will allow it to do it, but it's going to break the entire web. So any website that you go to, like Gmail, Google, and you try and log in, it won't work. It won't be able to set that cookie for you. So you can turn it off, but you do it at your own peril. Yeah. Then you can get extensions where you might turn off some cookies for websites. So that's another thing you can do. Another thing you can do is you can manually delete your local cookies. Okay. So this cookie jar is on your computer, and this is the thing that keeps appending the same cookie. So at any time you want, you can go and say, erase all my cookies. Okay. Once you erase all your cookies, then your browser stops sending them. You'll automatically be logged out of every website that you've ever been logged in because they won't know who you are anymore. And then the website will be forced to send you a new cookie. Okay? And it won't necessarily know who you are. But once you log in after doing that operation, then it can say, okay, these two cookies belong to the same person. Yeah, so it doesn't necessarily, I'll get to the privacy in a second, but yeah.
Yeah, if we go into incognito mode, will it stop using cookies in that?
Yeah, good question. So the browsers have a private browsing mode. I won't give the nickname for it. Or incognito mode. And so what it does is this is the policy. So what it will do is it will start with an empty cookie jar. So as soon as you open a private browsing tab, you have no cookies. When you start visiting websites through that, it will maintain a cookie jar. Okay, so it won't turn cookies off. It will maintain the cookies for you. But then as soon as you close the window, then it wipes the cookie jar. So what it does is it gives you a fresh cookie jar, but you can still add cookies to it, and then when you're done, it deletes that cookie jar. Yeah. So in private mode, it still works to like log in, and you can say keep me logged in and things like that. But as soon as you close that browser window, then your cookies are gone. Yeah. So it is better for cookies to use like a private browsing mode, but it doesn't stop all forms of tracking. Okay, let me go through some of the things that we said. Let me just draw them out so that they're very, very clear. All right, so let's leave. We'll stick with Google. I always use Google. Sometimes it's in good context, sometimes it's in bad context. So we'll balance it out. Okay, so here's you. Here's Alice. Brand new computer. Just turned it on for the first time. She sends her very first request to Google. She goes to Google for the first time ever on this device. Google has no idea who Alice is. Okay? But when it sends a response, it includes a cookie value. Okay? And so now Alice has her first cookie from Google. Okay? And then she goes and she searches for something. So Google still doesn't know who she is. Okay, it just sets a cookie. Okay, she hasn't logged in. I want to be very clear about this. Okay, all she's done is gone to google.com and it's shown her the put your search term here, but it did put a cookie on her computer. Okay, then she goes and she does some search for whatever, XYZ, and appended or prepended, I keep saying appended, prepended to the search is that cookie value. Okay, so when Google receives this search term, they know, hey, it's the same user here. Okay, then she goes away, and then tomorrow she comes back and she searches for something else. Her browser will see, oh, that's going to google.com. I got a cookie for that, so I'll append that value. So it puts the cookie in to her search for ABC. Okay, so Google still doesn't know who Alice is, but what Google does know is that there's some user out there, and one day they search for XYZ, and then the next day they search for ABC, and the user that searched for these two search terms is the same person. I just don't know who it is. Okay. Then the third day, Alice comes and says, hey, I want to log into my Gmail account. Okay. We'll assume it's at mail.google.com or some Google resource. And we'll talk about whether cookies, does a cookie that's set for google.com get sent to mail.google.com? I mean, they're kind of similar, but they're kind of different. There is some rules about that, so we'll articulate those rules. But for now, we'll assume that whatever the rules are that are set, that the cookie will get sent to both of them, even though they're slightly different domains. One's a subdomain of the other. So we'll append the cookie to it, and now she logs in, and she says, hi, I'm Alice. Here's my password. Gmail confirms it. So now what does Google know? Google knows, okay, this person with this cookie is Alice, and all of these searches that Alice did before she ever told Google who she was, Google now knows. Okay, so they know that she searched for those search terms, even though she wasn't logged in at that time. Okay, then what Alice does is she, this is from her computer. Maybe she gets a cell phone. So she kind of goes through the same process. She'll send a bunch of search queries. Initially, Google will think these are two different people. And then eventually she might log in from her cell phone, and then it will collapse them and say, okay, I know all these search terms on the cell phone belong to Alice. Furthermore, I know that Alice, when she's using her computer, has this other cookie value. Now I can aggregate all that information together, and I know everything that you searched on your phone and on your computer as well. Okay, so that's the next thing. Then the final little bit is, let's say that Alice goes not to Google. Let's say she goes over to whatever, dictionary.com. Okay, so something completely unrelated to Google. So she'll send a request to dictionary.com. And in this case, maybe dictionary.com sets some cookies or something like that. It has nothing to do with Google's cookies themselves. Okay, so she sends a request. Now, let's say that dictionary.com has a search bar from Google. Okay, so what they do is they create a little iframe, for example, and they say, okay, this is Google search bar. And what that means is that you're actually contacting Google to populate that search bar. Okay, so what dictionary.com is, they'll send you back a base HTML page that has a kind of missing hole, and they'll say, oh, by the way, Google's going to fill in what goes in this hole. Okay, so then what Alice's browser will do before you even realize it's happening, it will happen in a split second, is it will send, then what Alice's result is, she'll send a response back to Google, okay, and she'll say, hey, I'm coming to get this thing that I want to put into dictionary.com. This is going to Google, so here's my cookie. Okay, and then Google will send back the response, and it will get dropped into this website, into this search bar here. Okay, and so effectively, even though Alice went to dictionary.com, because she had a request and the request went to google.com, then Google knows that, oh, she's coming from dictionary.com. Okay, now it's a little more complicated. So when Google gives dictionary.com, like say the JavaScript or something here, it would somehow make it unique to dictionary.com. So it would know that every time this request comes for this exact resource, it's from the search bar that's on dictionary.com. Okay, so now Google has sort of followed her from Google resources themselves. I mean, it makes sense that if you're visiting Google, they kind of know who you are. Maybe kind of freaks you out that they know everything about your past before you even logged in, and they can link that to your current identity. But now they can actually trace you to a totally different site because that website happened to embed a resource from Google. Okay, so dictionary.com embeds something from Google, and therefore you go back. How many websites on the web embed things from Google? Is it a lot? Like, is it like 2%, 5%, 50%? So it's something like, I don't know, 70% or 80%. Okay, it's really, really high. Why? Well, what Google does is they offer you a bunch of web statistics. So they give you like this web developer kit, and you just kind of install it as JavaScript on your website. Now, every time a user comes to your website, they they'll know who that user is, assuming that user is using Google. So for example, let's say they search on Google for a search term. Your website is one of the responses. Then they click on that, and then they come to your website. Google can track the user through all three of those steps. And so they can tell you, hey, you got like a user who's between 18 and 25, and this was the exact search term that landed them on your website, et cetera, et cetera. Okay, so they give you all these like cool statistics, and you can see how many hits you've had on your website and like where they're coming from and all these different things. Okay, so it's very popular. People like to install it. I think I even have it installed on my website. But what that does is it allows Google to trace you from site to site to site. Okay, Facebook, similar. Okay, so Facebook has the like button, right? Or they have something where you're on like some website and you want to post that article to your Facebook. So there's a little Facebook button, and you just press it once, and then it pops up with Facebook. You're logged into Facebook. Maybe even on the website itself, it's like 3 of your friends have liked this article. Here are their names. How does that work? Like, is it that the New York Times figure out who your Facebook friends were and who liked the article and sending that to you? That's not what's happening. You're downloading the article, and then all the New York Times does is they make a little box, and they say Facebook's going to fill in this box. So then you go over to Facebook, and then Facebook figures out, oh, you're looking at this New York Times article. I see that 3 of your friends have liked it, so I'm going to fill in the box saying that 3 of your friends have liked it. And because you have a cookie and you're logged into Facebook, and you say keep me logged in, it knows who you are, it knows who your friends are. Okay, so that's how it's able to weave that stuff together and show it to you. Okay, how many websites have a Facebook button or some sort of Facebook relationship? It turns out that, like, if you look at the Alexa top 1,000,000, I've seen statistics like about a half, about 50% or something like that. Okay, so Facebook can also track you as you go from site to site to site, even though you're not actually dealing with Facebook itself. Okay. So anyway, this is like a kind of privacy concern. This is why tools like Ghostery were sort of invented to allow you to kind of give you some manual control and to track some of this stuff as well. Yeah.
Whenever I open any website, mostly first if I see the address, like how it is routing the request, I see it goes to CDN obviously for optimization, and then it goes to Google Analytics.
Yeah.
So that's what you're telling, that it's kind of.
Yeah, so Google Analytics is the web server of that service that provides what I was describing.
Okay.
Yeah. So yeah, lots and lots of websites have Google
Because when I
Analytics.
installed Ghostly, I was seeing Google Analytics almost everywhere.
Exactly. Yeah. So something like 80% of the most, like the top million Alexa sites have Google Analytics on. Yeah.
Okay.
Yeah.
Is it possible to send you my cookie? Like I would go to a login page, so like I would get a cookie,
Yeah.
and then I would it would be a Facebook login page. I would say, hey, check out this cool thing on Facebook, but for that you have to log in.
Yeah.
So you would be essentially logging in with my cookie.
Yeah.
So once you have logged in, I have the cookie number, or whatever the value is.
Yeah.
So does it mean I get your login access?
Okay, so this is going back to the same origin policy. It's going to protect that from you. Okay, so if I have a website and I embed something from Facebook, somehow this website knows who you are. You're logged into Facebook, but the question is, when that response comes back, does the website then learn who your friends are, right? Like say you're on the New York Times and it says 3 of your friends have liked this article. The website itself is from the New York Times. Facebook is populating some part of that website. Can the New York Times figure out who your friends are? Do they see your cookie from Facebook? Could they just go and turn around and log you in? Yeah. So these are open questions at this point. So I'll answer those questions, but ideally we want the answer to be no. Right. Yeah. And so there will be a way to do it and a way not to do it in terms of how you have to set it up. Yeah.
What if we are giving them the permission to log in, like we are on a website, we are logging in with the help of Gmail account.
Yeah.
And then we are giving them the permission that they can access our Gmail account. So how powerful that thing is? Can they access our real account, or they just have the permission to authorize our identity?
Okay. So the question is about, like, sometimes you go to a website and you're going to authorize them to do something with your Google account. Like maybe they're going to, like, for example, I have a travel organizer called TripIt. And so I have a setting, I don't have it set up, but it could scrape my email. So if it ever sees like an airline ticket, it will read that email, it will put it in my calendar, and it will add it to my travel organizer, right? And so I have to authorize read access to my email in order for that whole thing to work. And so the answer is it depends on Gmail itself, or whatever the web service is. So the web service itself is giving it an API, so like a bunch of functions that it can call. It itself will have some authorization token to it, so that Google knows it's them that are making that request to the API, and that it's about my account and that I've authorized it. So they'll have some system for tracking that. And then whether they give deep access or what level of permission, the granularity of permissions they give, that's up to their coding. So it depends on how they coded their app. Yeah.
Professor,
Yeah.
is there any reason for using a phrase cookie for this process?
Yeah. What's the history of it? I feel like there is a story behind the word cookies, but I don't remember what it is. Yeah. You can read the Wikipedia article. It probably will say what it is. Yeah. Someone, I don't know if it was like a joke or something like that. I forget the exact issue. It's not like an acronym. It has no technical meaning as far as I remember. Yeah. Other questions? Okay, let's go away for 10 minutes, and then I'll show you some of the details of what a cookie looks like, and then we'll get to the actual cookie policy in a browser. No, I discussed it at the start of class. I'll update the website, so it'll be due in a few weeks. Okay. You have a bit of time. Yeah. Go. All right, if everyone can sit, please. Okay, so what I did is I browsed over to my favorite website, dictionary.com. It used to be really, really bad in terms of the number of cookies. Now it seems like it's not as bad. It used to have like a huge list. Like I recall like almost 40 different cookies that was set. But anyways, I'm also hesitant because I'm putting this up on the web. I don't want to actually show my cookies because anyone who watches the video could just log in as me. But anyways, so you could hijack my dictionary.com. I'm not logged in, but you could make dictionary.com think that it's me that's asking about different words. That's the worst that you can do. So I won't click through all of these things and show you different cookie values. But anyways, this is what cookies look like. So you can see the fields that are involved in a cookie itself. So I'm going to take a screenshot of this, and then we'll move over and I'll analyze it. In order to get this a little more populated, what I did is I did adjust my browser settings during the break, and I want to make sure I turn them back, so I'll show you what they look like. So this is Safari. So they say prevent cross-site tracking. That's sort of like prevent third-party cookies. So it used to be called that. This is a more kind of descriptive thing. Another thing you can do is you can send in the header. You can send a request that the website does not use cookies to track you across different websites. So they're allowed to use them to, for example, keep you logged in, but they won't use them. They won't let you use them for tracking you across different websites. This is up to the website to comply with or not. So if you go to a website, for example, that's in Canada, and there's legislation that says that they have to honor this do not track flag, then they will. Okay, if you go to a website in some country that doesn't enforce this, then they might track you even though you tell them not to. Okay, so it's not technically preventing anything. It's more of a political solution to this problem. You also saw that because of different laws that were passed, that websites ask for your consent as well. So you didn't probably see that for like your whole entire life, and then all of a sudden you started seeing it everywhere, and you still see it probably. And so that's also in response to legislation as well. Anyways. Okay, so here's dictionary.com. This is their cookies that they actually have set on my computer. So some of them, oh, sorry, that's the expiration date. Okay. All right, so anyways, there's a bunch of different fields in a cookie. So what does a cookie actually look like? So a cookie will be set by a particular domain, okay? And so if the domain matches this particular domain, then your browser will send it back. Okay. There'll be some detail about what's called the scope of the domain, which I'll outline in a second. I don't think this shows it, but if I double click it doesn't either. Okay, that's fine. Okay. So these are scoped to a specific thing. So I'll come back to that because it's a more minor point. The cookie will have a different name. So as you can see, dictionary.com doesn't just have one cookie. It has a whole bunch of them. So how does it keep track of them? What it does is it assigns a name to it. Okay. So I don't know what these names mean. I mean, only dictionary.com knows what these names mean. But something like SID usually stands for session ID. Okay. So I'm guessing that this is the main cookie that identifies me as a user, and then these things are used for other various purposes. Okay, so this is kind of like my unique value, and if you put this in your browser, it would think that you're me. Okay, so every cookie has a value and it has a key or a name, so it's a name-value pair. There's the domain that set it. And the domain that set it can also say, what other domains are you going to staple this in? So your browser is going to look through your cookie store and look for dictionary.com cookies to send it to. And anything that matches dictionary.com, it will append it to or prepend it to. Okay, so that's how the website itself is, or how the browser is going to work. But it gets kind of complicated. Like, for example, let's say google.com sets a cookie, and then you go to mail.google.com. Is that the same domain, or is that a different domain? And so it turns out that it's actually up to the person who sets the cookie. So whoever sets the cookie, they also set a policy which says what other websites are considered a match for this domain and what websites are not considered a match for this domain. So that's called the scope of the cookie. And the basic way it works is you can have the exact same domain. So for example, let's say I go and I browse over to whatever encs.concordia.ca. Then this will only match encs.concordia.ca. So as long as I'm sending a request to this exact domain, then it will append the cookie or prepend the cookie, otherwise it won't. Okay. Now, what if I want to set a domain from encs.concordia.com, but I want it for any Concordia or concordia.ca, I want it for any Concordia domain. Okay, so you just go to the base concordia.ca. I want that cookie to also be sent. Then I can send it as a wildcard. So I do star.concordia.ca. The syntax here is a little different. You can barely see it, but there's a little dot before dictionary.com, so that means the same thing. So this is every super domain. And you can whitelist any super domain. So it's fine. You can't authorize all .ca. So that's just, it's logically consistent with how this policy works, but you're just not allowed to do it because then your cookie's getting sent to like every single top level domain in .ca. So it has to be something a top level domain. But similarly, if you were like say a.b.c.d.encs.concordia.com, you can jump up a couple domains. You don't have to go all the way to the top to concordia.ca. So you can go to any super domain. You can also authorize any subdomain as well. So you could do star.encs.concordia.ca. So for example, in this case, users.encs.concordia.ca, which is where my website is, that would match this particular case. Okay, so these are the three basic scopes that you can specify for your cookies. And so it comes from a certain domain, you specify it, and then it's either stapled in or it's not stapled in to every request that goes back to that particular domain. Okay, note www.concordia.ca is not the same as concordia.ca. Okay, there's nothing special about www. It's a subdomain. It could be www, it could be mail, it could be whatever. Okay, and so a lot of people think of it as sort of like the exact same. If you've ever done DNS things or SSL things, sometimes you run into trouble because these are technically two different websites. They could be at totally different IP addresses. So this might go to one server and this might go to a totally different server. Okay, so they're technically have nothing to do with each other. In general, we configure as a convention that these two things end up pointing at the same thing. Okay, but in terms of setting cookies, if you set a cookie that matches www.concordia.ca, it's not sent to concordia.ca. Okay, and vice versa. Okay, if you put star.concordia.ca, then it would get sent to www.concordia.ca. Okay, in addition, you have a couple flags. So we'll talk about two of them. Yeah, question?
Why would we want to set cookies that matches domain and subdomains, and why would we want to do that? What's the advantage of doing that?
So the question is basically, like say I go to google.com, I log in, and then it redirects me to mail.google.com. Does it want to know that I'm logged in? So you might, usually the most common scenario is thinking of session cookies and logging you in, not like just tracking, is that your server that you log into is actually a different machine than the server that serves up everything else. And maybe there's physical security reasons. You don't want someone to steal the password hash file off of it or something like that. And so you might go to like login. You might get redirected to login.concordia.ca, submit your password there. It's going to set the cookie, and now you're going to get redirected to mail.concordia.ca Concordia or users.encs.concordia.ca, and those sites want to know that you were logged in, but you were logged in at a completely different domain. And so that's why you want these cookies to sort of trace you around the particular website. Okay. All right. So there's two flags. So in Safari, the display is HTTP and secure. The more kind of verbose name is HTTP only. And secure. And this is like super confusing because they sound almost like they're doing the same thing, but they are not. So let me start with secure. What secure says is it will only send over HTTPS. Okay, so if it's a cookie and you can set it in the browser and you can say if you're ever about to browse to a non-HTTPS version of my website, then don't attach this cookie. Okay, so only send cookie if HTTPS. So some websites, like say you log in, but then you log out or something like that, and then you're about to go to the website for the first time and you just go to the HTTP version before you log in again, then it won't put that login cookie in. Okay, and so this is meant to keep it secure. Okay, now this sounds like it's doing the opposite. This is like HTTP only, like not HTTPS. This is why it's confusing. This actually has nothing to do with HTTP versus HTTPS. Okay, so what this says is send the cookie over either HTTP or HTTPS. We don't care. It's not about the S in it. But what we don't want you to send the cookie over is any connection that was opened by JavaScript. So when I run scripts on the website, that script can open up a connection to a new website. That uses a different protocol than HTTP. Okay. Well, it sort of uses it under the hood, but anyway, that connection's formed in a different way. And so in that case, I'm not going to form the cookie. So if I, for example, get some JavaScript that's running on your website and I say, go over to facebook.com, your browser won't put that into that request. Okay. If you typed in facebook.com and press enter, then it would go in that particular case. Okay. So we'll send the cookie over HTTP, HTTPS, but not over a JavaScript connection. Or ActiveX or whatever you want, but JavaScript's the most common thing now. Okay, so these are the two flags. So you can see in this case, some of these things are marked as secure, meaning they'll only go to https.dictionary.com, and none of them have the HTTP mark itself. Okay, questions about this?
So
Yeah.
So in contrast, like for www and plain one, like Concordia.ca and www.concordia, they use different cookies.
Yeah, so they're different. So let me relate this back to origins. So let's go right back to the top. So we have two policies. There's the same origin policy and the cookie policy, and they're almost the same. Okay, but they're technically two different things. So we're talking about this thing itself. Okay, but there's this concept of an origin. So an origin is where, in this case, who set the cookie. Also, it's kind of the destination as well, like where you're going as well. Okay, and so to answer your question, I forget the exact example you gave, but Concordia.ca and encs.concordia.ca are different origins. Okay, so that's what defines an origin. An origin is basically an exact domain, including the subdomain, plus the protocol and the port. But we'll get to that in a second. So they're different origins. Now, just because they're different origins doesn't necessarily mean that the cookie won't get set to both. Okay? It's up to you that when you set the cookie, you tell the browser, hey, I want this cookie only to go to the exact same origin. Okay? So actually calling this origin is maybe a better way. Okay? So you can set the policy to be only send this cookie to the exact same origin. Or you can say, hey, I don't care. You can send this cookie to other origins besides me, but they have to be a super domain of me or they have to be a specific subdomain of me.
How do you tell that?
So when you set the cookie, you basically send these values. So the website, the first time I go to dictionary.com in its response will say, hey, I want to set a cookie. The value of the cookie is SID. The name of the cookie. The value of the cookie is this funky looking number. Here is the scope itself. Okay, so this is .dictionary.com. So .dictionary.com is the same as star.dictionary.com. So it basically says either dictionary.com or any sub-resource is fine. Any subdomain is fine. Whereas the cookie above it, you see it's set to www.dictionary.com. That's exactly www.dictionary.com. It won't get sent to just dictionary.com, for example. Yeah? Yeah. So anyways, that's how you set it itself. And then you can set there's this path variable you don't have to worry about. There's also an expiry date, so cookies don't last forever. They eventually will expire. What does it mean to expire? It just means your browser will stop stapling it in. Okay, they won't staple it in anymore. It doesn't mean the server deletes its record of the cookie. It just means that the browser will stop sending it along with it. And then you can set your flags. And then the size, and whether it's the same origin or not, whether it's the size, the path. Well, the path is populated. We're just skipping over that. These two things are the browser just giving you some information about the cookie. It's not sent by the cookie itself. Yeah. I'll go back and then forward.
So if it's not expired, then the website will keep using it each time I log in, even if I log off?
The website doesn't know anything about, your browser doesn't know whether you're logging in or logging out. All it knows is you're sending something, you're about to send a packet to dictionary.com, and I see that matches this set of domains. And so I'm going to send that cookie.
I mean, usually you said earlier that the websites always keep our cookies saved. So even if I log out and then log in, it will use the same cookie again?
So it's up to the website itself. So the website could use the same cookie. It's an option for the website. It's the easiest option for them. They could go to the trouble of resetting your cookie, but that would be up to the website to decide. Yeah, exactly. So that's why they might refresh it. So they might say every time you log in out, we're going to refresh it because we want to make sure that the shelf life of this cookie isn't infinite, so that if it's ever stolen, then there is some like expiry date for it. Yeah.
Who checks the expiry of the cookie?
Your browser. So the browser will just say, is the current date different than this? And then it will or will not send it.
What if I change the date on my PC?
Yeah, so that's a good question. So this sometimes inadvertently happens. So sometimes, I don't know, you're out of battery or something like that and your clock gets messed up. And then websites don't work and things like that. That's probably because of this.
So if my cookie expires today,
yeah.
If I roll back to like 2 days, and can I still use it?
Yeah. So first and foremost, this is stored on your browser. This is under your control, right? Like this is something that you're storing. It's for you. It's not for the website. It's for you. And so if you want to make your cookie last longer than it does, you can just change the expiry date. That's a simpler way. But yeah, you could roll your clock back as well. But this is your store. This is your cookie jar. So if you want to manually go and flip the flags and make these secure, you can do that. Like the browser might not give you the interface to do it, but you can technically do it. Like if you can expose this actual cookie. Similarly, if you want to pull the expiry date back, if you want it to expire earlier, you could do that. Or maybe someone writes an extension that lets websites set cookies, but it only keeps them alive for a day, right? Or every time you close your browser, you want to wipe it. You can do that too. So this is 100% under your control. So you can tweak them any way you want. Yeah.
The sizes are like what we see is very small. So
Yeah.
are these information here is just a meta information or is actual the content of this?
Okay, so by meta information, I just meant it's in the meta information of the packet that gets sent.
Okay.
So your request packet, that's sort of where it lives in the request packet. But the cookie itself is literally what you see.
Oh, the value.
Yeah, so the reason that this one's 300 bytes and this one is 6 bytes is this one's only storing 3.5, right? Plus the name of it. Like you can actually count out the 6 bytes. 1, 2, 3, 4, 5, 6 kind of thing, you know? Like, so that's it. Yeah.
Okay.
Yeah, and so these ones have big long values. That's why they take more space.
Excuse me, Professor. Like, what's meta
data? Like,
Yeah.
Can you explain?
Okay, sure. So all I meant for it is it's sort of a term that's used in general for whenever you have content itself, and then you have the description of the content. The description is called metadata, and then the content is called data itself. And so this is applicable to all sorts of things in life, right? Like it's not just, it has nothing to do with web specifically and web pages and things like that. So in this context, it just means it's in the header. It's not the actual body of the request or the response in particular. It's in some sort of header field for it. So I don't want to go into all the details of HTML, but if you looked at the spec, you would see that they're split out. In general, metadata would be anything that's not the content. So like, for example, let's say I call you. A recording of that conversation, that's the content of the call. But your number, my number, how long we talked, the exact time that we talked, that's meta information. So if you listen to the content, you wouldn't know that information. But you could also learn that information without learning the content, right? And so then there's a big, like with law enforcement and stuff, when they go and they like get records from companies and things like that, sometimes they just get meta information, sometimes they get the content. And there's like policy debates about that. Yeah.
Like, can I forge a cookie and use it? It's like nobody checks the authenticity of the cookie, so I can easily forge a cookie and you can use it.
Yeah, okay, so that's a good question. So what if you want to log in as me? You have no idea what my cookie is, so you just try every value. Eventually you'll hit the right one and then you'll get logged in. Yeah? And so that absolutely applies. So you can do that. And so cookies need to be as secure as a password. So that's why, at least for these important cookies, like these sort of session ID things, that's why they're like such long numbers. In this case, they don't even look that long. But anyways, they should be long enough to resist the exhaustive search attack. There could be authentication on them further. So this is just a number, and you have no idea what this number means to the actual server itself. So this number could mean lots of different things. And so they could put a MAC on it with a key or something like that. So you don't actually know what they're doing. So it could be authenticated data as well. Other questions? Yeah.
You mentioned that some big websites like Google.com, they can use cookies to transmit to track us all the time. So my question is, does cookie has anything to do with the private browsing mode?
Yeah. So the private browsing mode will basically give you a clean cookie store. So you'll have no cookies that are installed. And whatever cookies were set when you were not in private browsing mode won't get copied over. So it's basically like buying a computer for the first time and using it. So you buy a brand new computer, you have no cookie set. Every time you open one of those windows, that's what happens. You will accumulate cookies as you continue to browse with it. And then when you close the window, they all disappear.
So my browser will just delete all the cookies in that cookie jar?
All the cookies that were set in that window. So it won't touch your real cookies, right? So you now have two cookie jars. So you have your original cookie jar, which is when you're not in private browsing mode. Then when you go in private browsing mode, it creates a second cookie jar. As you use private browsing mode, it adds cookies to that cookie jar. And then when you close that window, then it deletes that cookie jar, but you still have the original cookie jar. Yeah. Perfect.
Where is this cookie jar stored? You said it's in the browser, right?
Yeah.
So I guess it's like depending on the browser that I'm using, it's like in different locations.
Yeah, exactly. So your browser will store it in its own storage somewhere. Yeah. So there'll be a file somewhere in your browser itself that has the actual values.
Or something? Like
No. I mean, like, no, it's not encrypted.
It's
So.
not
Yeah. Yeah, and so this is like the web inspection tool, and so it's actually seeing the cookies that are on my computer at this particular time. Okay, other questions about that? Yeah.
Like you said, only browser can exclude the cookies once it gets expired. And don't you think that the server should also keep the records of the expiry date, because once it gets expired, like you said, the user can extend its expiry date, and still, even if it is expired, then why server is keeping that data even if it is not valid?
Right. So the server, it's up to the server itself. It probably does. So when it sets that expiry date, it probably remembers what it set. And then if you keep coming back after the expiry, it's going to be like, that's weird. But then how it's coded up is totally up to the website itself. So they could notice that it's past the expiry date, but the person still comes back with this cookie. Maybe that looks like an attack. Maybe they're going to make you log in with your password now. So it's up to the server itself. Like, we don't know what web servers do, and they're all different in terms of how they handle cookies. Some of them will just not check anything, and then other ones will be very diligent and look. They'll be looking at the cookies for anything that's unusual because that might indicate an attack, right? So like big companies like Google and stuff like that are probably putting a lot of scrutiny on cookies. And then a website that I code up in my spare time, I'm just setting the cookie and then like not doing anything with it to look at it. Yeah. Okay, other questions about this? Okay, good news. We're going to end class early. And yeah, I'll see you all next week.